Hi kidlets, this is the last portion of the Death of Massive Stars lecture. So in looking at how we can tell the ages of star clusters, we can see that there are clear turn-off points from the main sequence based on the age of the cluster. So remember that star clusters have stars that are predominantly the same age, the same composition. So you would have all of these that would be born about the same time. So here you can see that you have stars that haven't even reached the main sequence yet. But then after 10 million years, we begin to have this turn-off point. So the most massive stars have begun to turn off. And here we can see our lowest mass stars after 10 million years are beginning to move on to the main sequence. So then we can see after 100 million years that here again is our turn-off point. So we now have a few more giant stars. Our most massive stars have turned off, and almost all of our stars have reached the main sequence. So after 1 billion years, we can see that our turn-off point is steadily getting further and further down the main sequence. And after 1 billion years, we have every star that has reached the main sequence. So for our lowest mass stars, it can take 1 billion years for them to actually reach the main sequence. And at that point, we have our most massive stars, which are at the end of their life. So then after 10 billion years, we clearly have branches of each category. So now we can see the turnoff point is down somewhere near the mass of our sun. So as a star cluster ages, we can see that these turnoff points just get lower and lower. So now we clearly have a well-defined white dwarf area, we clearly have the giant branch, and we can see each different area of the HR diagram, each different phase of stellar evolution. So, and we can also see that some solar mass stars have reached the ends of their lives. So these would have been the white dwarfs, would represent stars that are sun-like, but more massive sun-like stars. So here we can see in this double cluster, we can see stars that lack a lower main sequence and the highest main sequence. So these would be about 10 million years. So remember that the region that's right here, this region has not reached the main sequence, and these have already turned off. So our youngest would be missing the lowest mass and the highest mass. So then we can see the Hyades cluster. This is also pretty young. So here we have a lower turnoff point. So this is about 600 million years. And we're missing the lowest of low mass stars. But we do have a few white dwarf stars. So this means it's got to be somewhere, give or take, around 1 billion years. This one in this case is 600 million years. So we have some red giants, but here's the turnoff point. So that means everything above this mass has already turned off the main sequence. So here we can see this one where we have well-defined branches, a well-defined white dwarf area, and not only a well-defined white dwarf area, but we also have some white dwarfs that are dimming, that are nearing the end of their white dwarf phase. So this would be indicative of clusters that are pretty old, even in universal ages. Like this one that is about 10 to 12 billion years old. So this is a globular cluster. And the only difference between a star cluster and a galaxy is the number of stars. Star clusters have about 30,000. In order to be considered a galaxy, it needs to have about 100,000 to 1 million, to 1 billion. So as we've already said, star formation is cyclical. Stars form, they evolve, they die. In dying, they released heavy elements into the interstellar medium. These elements then become parts of new stars, and we end up having this stellar circle of life. So here we can see the fates of the two different types of more massive stars. So here we have the giant phase, which is after a sun-like star has moved off of the main sequence, we experience a helium flash, which then becomes the planetary nebula because the helium flash marks the end of the giant branch. And after planetary nebulae, when you have that halo of gases that fades away, we have our white dwarf. Then for our more massive stars, we have supergiants, we have heavy atom fusion resulting in an iron core, then we have our explosive supernova, and next class we will learn about the product of supernova, which can be either a black hole or a neutron star.